দিয়ে আমি এক্ষুনি ইউটিউবে লোড করে দেবো না। চলো এটা এক্সপ্লেন কর।
Okay. Well, the wand and our experiment was really fluid. Now, when you think of fluid, you usually think of water, something that flows, and something that flows called Newtonian fluid. But there's this thing called non-Newtonian fluid. Non-Newtonian fluid it's outside of Newton's law. You can try touching it.
It's outside of Newton's law.
Yeah. And our hypothesis, we had two hypotheses. The first one was that if we bounce this ball on the floor and on the non-Newtonian fluid, it will bounce the same height. It will come up at the same time. But then we realized this was wrong. And you can demonstrate. We dropped it from my height at this. This is 2.19 meters. And we dropped it. Let's say it bounced up to my height, up to my chest. Now, our original theory was that once we bounce this, it will also bounce up to my chest. However, this did not happen. As you can see, it only bounced up to this much. And that's why we conducted our second lab. We wanted to see why it doesn't bounce up back to our chest, to his chest. And we learned about this new thing called inelastic collision. It means that, kinetic energy. When you drop this thing, every time it bounces back onto the floor, it loses its kinetic energy until it remains still. So it'll keep on going down. It's losing its kinetic energy until it stops. But then we learned that there's a catch. We tried that. They stored 45% of the kinetic energy to make itself into a solid.
So they absorb the energy.
Yeah, they absorb the energy to become a solid. For a period of time. We tried with different mass balls with different masses, different size, different mass size, different colors to make it different. Yes. So we cut up some exercises, and we figured out that something between 44 grams and 101 grams, it will always bounce. But anything above will also bounce. But when you try and bounce it, no, it won't bounce. It has enough energy, but then it doesn't have enough energy. It has enough energy to solidify, but then it doesn't have enough energy to bounce back off. So it can't carry its own weight. So yeah, it stays. The larger the body, the harder it is to put more kinetic energy into it. No, the easier it is to put more kinetic energy, but the smaller the body, the harder it is. So too small did not bounce, and too large did not bounce. So but large. This is how we did our experiment. Here's a video of our experiment. That's 219, and one person observed and should see how much it bounced. And then we did this try 3 times because we average it because we don't want it to. We don't know if it's correct. And we have our results over there. For our first lab, these are the results. And we have the weight of the horse over here, and the floor bouncing and the status after it bounces. So for example, this one, when it bounces, it will stay afloat.
It doesn't have enough kinetic energy to push it back up.
Yeah, that's right. No, that's good. It will stay afloat because it has less density than the fluid.
Okay.
So if it has more density than the fluid, it will sink. If it has less density, it will float. So that's the ending part.
This thing has enough.
So over here, it
sinks. It doesn't sink completely, but it sinks down.
And so we tried many different objects. Some sunk to the bottom, no matter how small they are. Some stayed afloat. Some bounced out. For example,
we saw that 3 balls bounced.
This one bounced out.
This thing bounced. Where's the red ball?
So, but that one though is not. That one has air in it. So wouldn't that make a difference?
Yes,
like
because it has the air in it, it's less dense.
But that one didn't bounce.
Yeah, because density is also a matter in this. Because
But your hypothesis relates them to the floor as well as your non-total.
yes, we try to be over here. We have the height on the floor. So over here, so in this one, for example, the blue ones represent how high they bounce on the floor. And then again, on the second one, we had non-Newtonian fluid bouncing at that height. And we conducted this, and we got with the red ones bounced. That means the tennis ball, the foam ball, and the soccer ball bounced.
Where did
So these are the ones. And then later we checked out the mass. We just wanted to see if mass had anything to do with it. And this result shows what happened when we used the mass. So the things are in the weight field. So same in the weight field bounce. The floor, it's a bouncing height. Over here, the red one. So this is how high it could have bounced
on the floor
Then we have water. Water did not bounce.
at all? It just floated.
And the non-Newtonian fluid. The non-Newtonian fluid, if you see very carefully, only three. First one, the foam ball, and the soccer ball. These are the only ones that bounced in the entire. And this is the last one that bounced. Yes. So these are the ones that did bounce. We found out the mass, and we found out that 44 grams to 101 grams, they did bounce. And the only ones that were in this category was this one, and the tennis ball. Anything heavier or lighter than that did not bounce. Then we wanted to ask the question why. Then
শোনো জুতোটা বেঁধে নে বাবা
because it took off all of it. It had little,
So like this one.
this one is tight.
So when it bounces, it has only little amount of kinetic energy. So when it drops to the Newtonian fluid, it reduces even more.
This would be 2.9. It already had a small amount of kinetic energy, but then if you take 45% of it, it has less, so it can't bounce. It can't return. And so that's why we found out that only 44 grams to 101 grams object will bounce, and then 101 grams were because it had enough power, because it has enough electricity. The thing is, when it bounces, when the kinetic energy is absorbed, it doesn't have enough energy to make itself bounce. So it can't even carry it away.
So tell me this.
Constant.
The ratio of the fluid.
To the constant, so it's the ratio of how much cornstarch we use to water, and the balls, the height at which it was dropped from. The height would have always been same because it was dropped from me at my maximum.
Dropping height. And the ratio of